So let us look at it. This one, lucky for us, it has been arranged in that order. The dz, this is the dz dx, so maybe I can write it to y squared dz dx. Look at this. We said that if you remember the main rule, there's always a plus here. So there's a plus. This one I'll call it minus xy. Then this will be dz dy for this is equal to x z minus, because this part there are no derivatives here. Okay. So the moment it is in that form, we have dash equals dash equals dash. We turn this upside down. Dx y squared dy minus xy. Then the top is dz, so dz over x z minus 2y. Good. Then we pick pairs that are solvable. So let's just look at pairs that are solvable. If I look at the first one that I pick and see whether they are solvable or not, I pick the x over y squared dy over minus xy. Let's put it in the simplest form before we check whether it is solvable or not solvable. I can multiply through by y to get the x over y is equal to dy over minus x. I've multiplied through by y. Good. So y one of this will vanish and this one too will vanish. So we have this. This one is solvable because it is made up of only two different letters. I can group all the x on one side and all the y on another side. So it is solvable. Good. So here, grouping the x, minus x dx is equal to y dy. Integrating, minus x dx is equal to integral y dy. So this is minus s squared over 2, y squared over 2 plus c. So I multiply through by 2. Minus s squared, y squared plus 2c. I bring this to the side. Minus x squared minus y squared is equal to 2c. I multiply through by minus. So I multiply through by minus. I will have x squared plus y squared is equal to minus 2c. I replace all these huge constants by a simpler constant, c1. I replace minus 2c by a simpler constant, c1. So I've gotten one solution. Now, let me pick, so this one I pick this and this, and I realize it's solvable. Okay, I'm going to pick another one and check whether it's solvable or not. I'm picking this and this. The x over y squared is equal to dz over x z minus 2y. Remember I said that before you check whether it's solvable or not, put it in the simplest form. This one, I can't cancel. Can you see that I can't cancel? If I multiply through by y, even though one of this will vanish, the y that will come, you cannot cancel anything. Here there are three variables. There are three variables. That is not cancelling. So it will be difficult for me to solve it. All that we have been doing, there are two variables, the x and the y, with dx, dy. But here, there's x, well, there are three variables. None of them is vanishing. X, y, z. None of them is vanishing. So this one is an error. Okay. So let's pick another combination. The first one we did here, we picked this and this. The second one, we picked this and this, which is the error. So the last one, let's pick this and this and see. So we have dy over minus xy equals dz over xz minus 2y. Can you see that this one we can multiply through by x? Yes. We can multiply through by x for this to vanish. So multiply by x. We get dy over minus y is equal to dz over z minus 2y. Here there are only two variables that is left. Y and z. So we can solve it. We can solve it doesn't mean that you have to integrate straightforwardly. Check the appropriate method. So here what I can do is that since I cannot group y and the I cannot group the y and the z. So I can cross multiply. So let's cross multiply. Cross multiply, I get z dy minus 2y dy is equal to minus y dz. I cross multiply. Here I can integrate both sides. So I integrate z dy, I integrate 2y dy, I integrate y dz. This is something interesting that we have solved before. Is it exact differential equation? Yes, I think one of the linear differential equation. I think one of the differential equations that I said that these two they look alike, but one is less complex, one is more complex. I don't know whether you remember that thing that I mentioned. You see that this is z dy, this is y dz. So you solve this. This one is easy to solve, so we won't touch it. We'll solve this, but this one won't solve it. We will leave it. When you solve this one will cancel this. The solution for this is the one that you cover the d. Then use what is on the right of the d to multiply what is on the left of the d. Then when you finish, you produce the other side here so that they can cancel out. This is that method. Because they look alike. They look alike. They look alike. So let us use that one. Well, you are welcome back. We have what the last thing that I wrote is z dy minus 2y dy is equal to minus y dz. Here we use integration by parts to solve. This and this look alike, so we'll solve it. This one is easily to integrate. So this one we'll use integration by parts. For that short method that I taught you, that you cover the d, then use what is on the right to multiply what is on the left. Then its twin here, you repeat it as part of the answer. So I cover this. This time this gives me yz. Then in order to cancel this, I need the whole of this here again. Y dz. Then when you integrate this, you get minus 2y squared over 2 is equal to minus y dz. So that this can cancel this. So we have yz minus y squared is equal to 0. So let's compare the two answers. The other answer was s squared plus y squared is equal to c1. Then this one is equal to 0. So remember the rule that when one of them is equal to 0, you have f of the other one, which is not equal to 0, close is equal to the one that is 0, so yz minus y squared. This is the solution for the Lagrange linear equation. Very simple and very interesting. Yes, you can ask questions in case you have one. If not, we will continue.